Yo, 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 what's up, what's up, what's up? Welcome back, everybody. Today we are working on our video editor, and today's topic is trying to render video frames from Zig, the language that we've written our program in, but through an OpenGL context provided to us from Rust. Now, why the heck would we do that? Okay, so what are we even making? We should probably start there. We stream around here, we stream ourselves coding, we produce VODs of these streams like once a day for around 2 hours, and these all go up to YouTube. And I feel like possibly a 20-minute cut down of these streams should also be uploaded. Because I think that, like, if you're trying to keep up with what's going on, you watch 20-minute videos at 2x speed, you only have to invest like 10 minutes a day into that, and you might get something that's almost as good as watching the 2-hour video. There's probably going to be more that's in the 2-hour video, but, you know, maybe that's like compelling enough that it would attract a new set of viewers, or even the same set of viewers that have less time, right? And so I wanted to experiment with that. I don't know if it's going to work out, but I tried once. I like opened up KDN Live, a Linux video editor, and holy, I think cutting down like a 2-hour VOD would take like at least 4 hours. I spent like so long just on like the first 5 minutes, and I'm like, oh, this is like not a trivial task. Maybe it's a skill issue on my part, right? Maybe I just suck at video editing, but it wasn't trivial. And so what I'm thinking is, well, we are programmers here. We can just create tools that fix our problems for us. And so what I'm imagining is, here's my little ASCII rendering of my video player. And what I'm imagining is, like, here's a little, you know, your typical video timeline at the bottom. Here's a little, like, nub that you can, like, drag around. But on the right here, I'm imagining a script of the video, right? So I'm imagining I run this whole VOD through some, like, subtitle generator. I'm thinking, like, OpenAI Whisper. He's going to tell me where each word is in the video, and I'm kind of hoping that if I scroll through the script that's generated, I could maybe select segments that I think are interesting and get some like handlebars in the timeline that I can like wiggle around to like clip things a little more accurately. And then I want to be able to see like, okay, so there are these clips over here that are enabled, these clips I want to like disable those, and I want to be able to like play back this like cut down thing and iterate quickly. So on the script side, I'm kind of thinking that there should be some indicator of where we are in the script as we're playing, right? I'm also thinking that there should be some sort of highlighting for as we adjust what clips are being generated. Okay, that's the background. So, why are we using Rust here for our GUI? I was looking at a few different GUI frameworks. We've written everything so far in Zig, so actually let's start with that. Where we're at right now is we have a video player. So we can play video, we have sound, great, but it doesn't really do much. You can't really seek or anything, and so it's like, well, it's time to start adding the ability to like drag around and see where you are in the video. So it's GUI time. And so I was looking at like a few different GUIs. I looked at like Qt, I looked at Nuclear, I looked at Dear I'm GUI, which would all be good fits for this project because Zig has pretty good interop with C and C++. But in order to get what I need on the script, I think I need to know exactly where every word is laid out in pixel space. And vice versa. I need to be able to go, like, if somebody clicks on a word, I need to know what word they clicked on. And if I want to render something by a word, I need to know how to do that. And looking at all of these GUI frameworks, it didn't look very easy. But on eGUI, which is like a Rust GUI framework I've been using in the past, it is very easy. There's just this like galley type. Let's see if we can find this. So if we go to eGUI here, there's this galley type where basically you say, before I like render this label of text, can we lay it out first? And this will give you like these like rows, and in each row, they have a bunch of glyphs, and in each glyph, they have like which character was this glyph for, and what is its position, which is like exactly what I need. And I don't really understand why every GUI framework doesn't like expose something like this. It seems like obvious to me, but maybe most people just don't need it. So this is the only GUI framework that I came across where this is trivial to do. And so we are working with Rust in Zig in Rust, right? So here's kind of what I'm thinking. I'm thinking we have Zig app, and he lives over here, and he's going to do almost everything. But then over here we have Rust GUI. And the question becomes, well, how do we get stuff from one area to the other? So what are their responsibilities? The Rust GUI is going to like open up a little window. He's got like a little X button over here and maybe like a title bar. And he's going to have like, you know, the video player in here with a little timeline and like the script and stuff, whatever. But we're going to try to keep this as minimal as possible because I feel like I'm never happy with any GUI framework. That might just be a me problem, but I would really, really love to keep the ability to swap all of this out. So what I'm thinking is we can like take this stuff and continue rendering him on the Zig side. We can keep all of the player state on the Zig side. So Zig will just say like, hey, here is where we are sitting here, and here is the text in my script, and like here is where in the text we are. All of this is going to be handled by Zig, and Rust is only going to be doing like displaying of stuff. The problem is that since Rust's the GUI side, his job is like create this window. He is going to own the OpenGL context, which means that in order for us to be able to like render this video, we need to basically provide Zig all of the functions that it needs in order to do that. And with the way that eGUI is set up, it's not like super trivial. So what we're looking at today is how can we provide, we're trying to basically get this part working where we can render a frame from Zig from the Rust GUI that's launched by Zig. What we have so far is we have these like C APIs to like run the GUI, and we have this like thing that's on like the Zig side that has like some state associated with them, and we provide that to the GUI. And so if we run this right now, our Zig build system calls the Rust build system, and we have like this eGUI thing, and you can tell like when I start hovering over here, the number on the bottom like starts increasing rapidly because every frame eGUI is calling to Zig and increasing this like number. And when we close this guy, Zig says like, hey, my state was updated. So we have like this way to interrupt between the two guys. And now what we want to do is we basically want to provide all of the OpenGL callbacks that Zig needs to render a frame to Zig. So we have this header that's in C. It's kind of funny because none of the project is in C, but the glue code has to be. So we have this like GUI header, and he just says, hey, here are the callbacks that I want. And then from the Zig side, we call this GUI run thing, and he is going to call back into Zig and say, hey, here are my OpenGL callbacks. And then later we're going to add something that's like render. And this is going to like use those GL callbacks, but we haven't really got there yet. Is eGUI really that much better than ImGUI that you opted to Rust? The only thing that I care about is this glyph thing. I looked at ImGUI, like, so the other option would be for me to do manual text layout myself, and I'm trying to avoid that. What is the galley type? It's basically this, like, you write some text, you give it to eGUI and say, here are the bounds of where that text is going to go, and the galley is like him laying out that text, but not painting it yet. So he will know where each character is going to go and what glyph represents that character, but he hasn't actually rendered it to the screen yet, which lets us do stuff like draw stuff before it's painted, like highlights behind and stuff. So if I'm wrong, and this is like an easy piece of information to extract out of Qt, then maybe I can go back. Isn't this too much complexity? I would personally rather stick with one language. Seems like sooner or later this will lead to some troubles. I think that there's no shot that that I'm going to get a GUI framework in Zig that is like polished yet. So I think that there's going to be some sort of C API anyways. I think that working with a C API is not that hard, really. And like, to be honest, like I think it's every language is going to call out to C, and like being comfortable with interroping between languages is not that, it's like a skill that we should be comfortable with. So it is a little bit, not a little much, but I think that it's worth it, because also I think that every GUI framework that I've used kind of pisses me off in some way, and I would love to just have one that works well. And I would love to be able to interact with that GUI framework from any language I'm working on. I just think that that's like something that would be nice to have. So having this ability is worthwhile, I think. Okay, so I think the first thing to tackle is let's try to get some OpenGL callbacks into Zig. So this guy, right now we only have this like hello world thing that just prints something from the Zig side. And I think that like this, with the way that the OpenGL callbacks are handled in like the Rust GUI framework, they use this guy called Glow, and he has a state associated with him. So we're going to need to have some user data in this struct. And I'm thinking that what we're going to do is like in Zig, right now we have our GUI, and we call a bunch of OpenGL shit. And so I'm kind of thinking like, we'll just expose the functions that we need. So maybe we start at the beginning, and we just start at shader compilation. So here we're going to have some function that's GL create shader. We're going to try to match it close to what we had. And he's going to pass in whatever this GL create shader parameter is, which is a... we should be careful here. I wonder if we can do GL enum and include gl.hr. I actually don't know if this is reasonable, but this seems like a good idea to me. And then what we can do is shove the user data in here as well. So on every function, we'll just pass this user data back in, and that will allow the Rust side to have the context that it needs to do what it needs to do. Which kind of means that this guy, does he need a user data parameter? No, because he's part of the struct. So I think we're chilling. Now, let's see. On the Rust side, what does that look like? We have this callbacks thing that's like generated from bindings. We have like the structure in here. And so we just need to say GL create shader maps to some function. And I guess we're going to have to generate that function. So this is going to be like extern C. No, it doesn't have to be extern C. It just has to use... Oh, it does have to be extern C. It's extern C function. It doesn't need to be no mangle. It just needs to be like C calling convention. And he's going to have something that's like GL create shader. And he's going to take in a C bindings GL enum. And user data. Sorry, this is, how do you do this in this language? It's like this, I think. Yep, and user data, which is going to be a void pointer. JSON syntax is not valid in a Rust item. Oh, function. I forgot function here. Okay, and then he's going to call, he's going to cast the user data to something. So I guess the user data is going to be a glow context, probably. So I guess we have to look at the eFrame docs. Let's see, eFrame. He is going to have some sort of, I think it's a frame type is what we have access to here. And in our frame type, we have this GL context. So I guess we can just provide, we can choose what the type of this thing is. So let's just make it a glow context. I think that's fine. So let context is equal to a, how do I get a glow handle here? Is it re-exported by eFrame? I actually don't know. Use, oh yeah, it's here. Yeah. So we can pull in this as a glow context. And this is equal to user data. And then we have to cast, and I don't remember how to cast in this language, so we'll just let the compiler yell at us. And then we'll call context GL, or create shader. I guess we need to import has context as well for these functions to be available to us. And so then we can say create, we have to dereference him. Create shader. Yeah. And then we can pass in value. Sick. Okay. Which means that we should be able to shove this function now here. And seems fine. Unsafe extern function, maybe? I don't know where they want this. Okay, so let's see if this builds. I don't know why it's decided now that it needs to rebuild all these dependencies. That seems odd to me, because it compiled like just a second ago without doing that. The current OpenGL context is implicit per thread, global state in all environments. I think it's more or less a thread local. Not sure if you know that or if it's relevant. So I think that there's a difference between the OpenGL context and the GL bindings context. So I think Glow is storing all of the function pointers to the things that we need from OpenGL in a structure that we need to pass between threads. He's mad because GUI common.h is mad that I didn't put a semicolon here. Okay. Give him a sec. He's got to think. He's compiling. It's a hard life for him. Missing user data. Oh, interesting. So I kind of want the GL callbacks to like live in static memory. So maybe what we do here instead is we set the user data here. And maybe caching it here is wrong, and maybe later we'll just pass it in on every iteration. I don't really know yet, but we'll see. We will see. Missing user data still, which is kind of annoying because I thought that this should recompile. Probably our build script here is not correctly rerunning, so we need to do like rerun if changed cargo. Wouldn't glad get you the same function pointers if the context is implicit? Yeah, maybe that seems possible, but I think that you need to worry about like if there is a collision between the GUI implementation's like OpenGL loader and ours. I'd rather not deal with reloading the same function. Like I'd just rather not try to load the OpenGL context twice. That just seems like it's like going to be a pain in the ass. Not that this isn't a pain in the ass. But you know, I guess I'm willing to take that hit. Okay, so this we can say, here, this takes in a parameter GUI header, and then over here, this is GUI header, like this. Do I need to provide a type here? Stir. And then he wants it to be uppercase, so fine, we will allow it. Let's see if we rerun. Okay, so now what is he complaining about? What is he complaining about? Rerun if changed. He doesn't like using ... in here probably, so maybe we'll just stick. What a pain in the ass. What a pain in the ass. Can we, for now, just get away with doing something like GUI comma.h? I just don't want to like worry about fixing in both build systems right now. Found a cargo key build value which is reserved for future use. Cargo. Does he want this? He's saying something about note the single colon. I don't feel like I've hit this before. This is surprising to me. I just assumed the bug, by the way, which is kind of funny. I could have probably got away with something else earlier. So how do I do this, like, casting again in this language? He wants me to cast this, so... Rust cast pointer. Casts. Okay, shut the fuck up. I don't care about safety, just give me... How do I... Here. C void. As. Oh, right, I just write as. Like this. Cool. And so now when I call this guy, I need to maybe set the context from the constructor here. And here we should maybe have this guy. I think it's like this. I guess we should make sure that the types match here, because this is going to be a pain in the ass, so. Let's do... I guess this should be a const glow context, probably, actually, to be honest. And then... let's kind of copy this down here, and down here we'll say... context, or let user data is equal to this, which comes from our context. I think all of this works like this. Then we can say user data as mute const c void. Mute c void, maybe? Okay. Here we need this to be as ref. And expected const context found arc context. Can I hit star again? little and star star. There we go. Looks like that builds. Cool. Cool. And then I guess now what we should do is just test on the Zig side if we can call that function. So we were kind of playing with just this like random Zig render here. I guess here instead of calling, here we need to say that we take in our user data parameter, which is a C void. No, any opaque in this language. Then we're going to say that our context is equal to the, this should, oh, we don't have to do anything with the context. We just use it, we just pass it back. So we'll say callbacks, and we'll look at GUI common.h. So here we're going to say GL create shader, and we're going to try to call it with CGL vertex shader. User data. And we'll see if that crashes, at the very least. If it doesn't crash, we're on the right track. No field or member function named GL create shader in callbacks. Pretty nice theme. What is it? This is Sonokai, but in Alacrity with term GUI colors off, which makes it look a lot like Grovebox. But it's not. It's just like, who knows what these colors are. Okay. Now let's see why this isn't in there. So GUI common GL create shader. Why is this guy not recompiling? Did I misspell this? No field or member function named GL create shader. So interesting. Interesting. So what's in czig? He is including GUI common. If I delete hello world in here, does it reset? Let's try this. Okay, so that's mad on the Rust side, which is not helpful. So let's go to the Rust side and comment that as well. So I just want to see... It could be that we have a bug where the Zig build system isn't correctly rebuilding. Unused function parameter in main.zig 43. User data. Okay, so now he knows that there's no field named hello world, and if I go back to GUI common and I uncomment, I add him back, the Rust side's gonna get mad. God damn it. God damn it. Okay, but maybe everything will pull itself together now? Not really sure. I feel like there's like, I'm concerned that there's some sort of caching problem in the Zig's build system that, yeah, okay, I don't know. Let's try calling GL create shader again, and it's still broken, which is interesting. Oh no, he's just saying pointless discard. So maybe it's fine now. No field or function member named GL create shader and GL stuff. What the fuck is going on? Arm Zig cache. I'm concerned. I'm concerned about the caching. Come on, buddy, you can do it. Yeah, interesting. So can we look at maybe... What is it generating? Zig cache output. GL create shader. What the fuck? How the fuck did this happen? So he's prefixing this thing with glad. Probably because the function name matches and it's doing some like stupid conversion. Okay, so there's like some sort of like coherency issue there. But we can probably dodge this completely by just getting rid of glad and glfw. And then in main.zig, we'll just not include GUI for now. And then we have to kind of go down to where the GUI is and kind of comment them out for now. We'll bring them back later. But let's just get ourselves compiling. Okay, cannot call optional type. Okay, so what's going on here? In our set callbacks, we do need to do this. Okay, and then we can run this. And it does look like it didn't crash at least, which is a good sign. Right? Like if we were to go into lib.rs and instead of like when we pass in the user data, if we passed in here stood pointer null mute instead, I think we should see a seg fault here. Because yeah, okay, good. So there's indication here that we are passing the user data to the right spot and it's making it back into Rust in the same way. So that's really good. Now, what's interesting here is this can return an error, which kind of indicates that on the Zig side, we should get some sort of error from our API, which kind of indicates that this guy should return an int maybe. And we will just, you know what? We'll ignore errors for now. And we'll just say, what the fuck? Where did I just go? How do we deal with errors in this language again? Jesus. If let error e is equal to this, can we just like e print line failed to create shader? And we'll just kind of tank that error on the Zig side for now. Maybe we should propagate it, but I don't want to because I'm a lazy piece of shit. This works. Probably we are just going to have to start like ripping through these OpenGL functions. And it looks like the using GL enum there is working okay, which is good. I kind of expected that not to. Yeah. Come on, bud. Come on. There we go. Your self-esteem is showing. I don't know what that means, but I think my self-esteem is quite high. So I don't know if you're either wrong and misreading something, or you're saying that I am showing high self-esteem. But I don't really care, I guess, also. I shouldn't have acknowledged that message. But it is what it is, and we move on. Okay. So, what else we need? We need GL delete shader. We need who takes in where am I gonna find this? Glad.h. GL delete shader. God, GL delete shader. What's like the fastest way for me to bang these out? GL uint. Okay, I guess, yeah, that's probably fine. It's probably fine. Okay. Then GL shader source, who takes in the uint shader source, as well as, okay, GL shader source. He takes in a shader, a GL size I, a const GL car star star, as well as a const GL int length pointer. We forgot a close brace here. And okay, create shader, delete shader, shader source, GL compile shader. I think maybe what might make most sense here is maybe to stub out all the functions first, and then we can start working on, we'll error log them or something, and then we can start running it and at least making sure that we can get, like, we can go through them one by one or something. Like, that's probably a little nicer. I think. GL uint. Okay. Okay. What is next? Create program. This needs semicolon. GL create program. Okay. GL delete program. Oops, I keep forgetting to close the brace here. I wonder why that is. Maybe out of habit. Oops, GL create program has to return the program. Which means that GL create shader also has to return the shader. This stuff doesn't matter. This stuff doesn't return anything. This does. This does. Okay. Then we have GL delete program, which must take the program in. Which takes in a GL unit. Boom. And we create program, delete program, attach shader, which must take in two GL uints and a void star, and then a link program. Okay, looks like that's all going okay. And let's see, let's maybe just stop there, checkpoint there, and start dealing with compiler errors. So 13. Oh, he doesn't like this because this is supposed to be like this. Okay. Now all of these guys on the rest side need to be implemented. Okay. Oopsies. I probably wanted to keep that up. Props for actually coding and interacting with chat. I found it impossible to code while streaming, even with 2 viewers. It's pretty hard to formulate your thoughts out loud, but I think it's... I hope we're doing an okay job. I hope. I guess for now... Does it make sense to print none in all these? I think no. Can we maybe make a macro? Like their like stub function. And he takes in something. I just want to avoid like typing the same shit over and over again. But I guess it's fine. We can do it. I think we can do it with some Vim macros because we're going to need to implement these guys anyways. So I think it's okay. So this is going to turn into unsafe extern C function. Then we're going to jump to this brace, close it, and then stub something else. It's so nasty. It's actually so nasty. GL delete shader. This comes from C bindings. This is the shader, and this is the user data. Just our mute C void. And we'll write unimplemented here, maybe. And I actually think it might be easier to copy paste this than work from where we were before. So this is going to be GL shader source, who's going to take in a shader. This is awful. There's a lot that's not right in here. This is not nice here. I wonder if it's easier if we use C bindings star so that at the very least I don't have to like write C bindings everywhere. C bindings. Yup. GL create shader needs to return the U32 or GL uint, which means that we need to return here. We need to match on this create shader. And OK V just returns V, but error E does this print line. I guess. Maybe eventually we'll find some patterns here. Expected U32 found native shader. Oh, that's a pain in the ass too. Okay, so how do I... Let's look at this thing. Has context, native shader. Where does native shader come from? Create shader returns self shader. Glow docs.rs. This is a pain. Native shader. So this thing... Oh, I just have to return this .0. Okay, that's fine. Not the end of the world. Okay. And this we just have to return. Oh, so now we actually do have to flag the response, which is probably just is there like a way to get max? I want like the... Can I do like GL uint max like this? Or is that not defined? Looks like it is, which is kind of nice. Kind of nice. Okay. Yeah, okay, that works. GL delete shader. So here we can say GL delete shader is equal to some GL delete shader. This, and then he's gonna just get mad at the rest. So I guess, unfortunately, I think it is going to actually be easiest to start with copy pasting the function pointers. Blech. But it's okay. We'll just work through it slow, and we'll live. If only we used less functions. Unsafe, extern, C, function, GL shader, source. He takes in a shader. He takes in the... what are these? GL shader source. What are these parameters? Count. This is S for string, and length here, and user data here. Unimplemented. Okay, what's going on here? This needs to be mute C void. This needs to be pointer lives on the left in this language. I think it's star mute star const. Is that const glcar star stars? That's star mute star const, I think. Gross. And I actually do want some sort of confirmation that I'm doing the right thing. So maybe we just stub everything out with none for now, and then come back to it. Why isn't this right? Why isn't that right? Is it right now? No. Missing GL attached here. So it looks like the language server is just fucked. That's really cool. Really cool. That'll make this go a lot slower, which is really what we want. We really want this to go even slower than it's already going. But we'll live. So delete to star, come here, and write none here. So much stubbing. Yeah, this sucks, to be honest. To be honest, this blows fat balls. Okay. Main.zig 45. This is ignored. It's okay. We can just ignore this for now. Okay, so at the very least, this is compiling. So now we can... Oh, let's apply here some GL shader source. Make sure this compiles. Which it looks like it does. Chilling. Okay. I guess I'm just gonna disable the language or LSP stop because it's so fucked anyways that it might as well not be running. Because it'll just slow us down. And I guess we just go through these one by one. Unsafe, extern, C, function, GL compile shader. It's the shader and user data. We need to convert the void star to a star mute void. He returns nothing, and he's unimplemented. And then down here, we can write some GL compile shader. Okay. Okay. This goes on the right side in this here. This needs an unsafe extern C function. This gets renamed to GL create program, and all he takes in is the user data mute void. C void, not void. C void on both of these. Unimplemented. Which means that now here we can write some GL create program. I know this sucks, but I think taking a one-time cost like this is not the end of the world, to be honest. I think, you know, sometimes you just have to live with this shit, and it will make the rest of our lives fine. So, eating the cost one time, even though it feels bad, is not the end of the world. Not the end of the world. User data, mute void star. Although the programmer in me wants to immediately automate this, and I don't know, I suspect that the automation would take longer than just banging it out. You know? You know? Maybe this is one of those cases where I should actually use AI tools. Maybe. But I'm not going to do that. I'm not going to. GL attach shader. And his parameters are... Is it program shader or shader program? What order these come in? Who knows? Program shader. Program shader user data. Unimplemented. This is the type of thing Copilot's actually good at. Yeah, this is the only time I've ever felt like I wish I used it. Ever. Staff engineer vibes. Yeah, just like banging out the same function over and over again. GL link program. And GL link program takes in just the program. Okay. Maybe we're going to get better at this over time. It doesn't really feel like that actually took as long as I thought it was going to. Okay. So let's maybe in main.zig, maybe we'll come back over here and try to actually compile a program and see how fucked up it gets. So we can do something like, just on set callback right now, wherever the fuck that is, here. Let's try to compile a shader. Is attached shader correct? 2 versus 3 params. Oh, the third, everything has an extra parameter here because we have user data being passed back and forth. But that's okay, we'll live with it. Okay, so I guess we want to go to GUI zig, and let's start by just copy pasting our vertex shader compilation. And I guess we could probably do vertex and fragment shader. Oh yeah, let's just see what happens. So everything here is C goes to callbacks, like this. This is a pointer type here. It'd be nice to maybe dereference this guy, callbacks, so that we at least don't have to write an extra dereference everywhere. So we'll call this callbacks in. Or maybe we can just write that this is a pointer for now. And we'll lie to Zig, and maybe he'll be okay with it. And then all of these guys need to have a dot question mark in front of them, which is a little bit annoying, but it is what it is. And then all of them need user data passed in. Okay. So then when we compile the shader, yeah, all that should be fine. And we should be able to do the fragment shader as well. So this is now callbacks on everything where we used C. And all of these guys have optional dereferences in front of them. And that's our fragment shader, and then we can compile and link our program. And if everything goes well, we won't crash here. That would be a big win for us, to be honest. I expect worse, but we can dream. We can dream. Although this probably won't compile for a little bit, actually, now that I'm looking at it. There's a lot of reasons why this won't work. in its current state. All of these guys need the little dot question mark on them. And vertex shader source is undeclared. So where does that come from? We'll just copy paste this as well, because we are in prototype everything is fucked land. So this comes from GUI vertex GLSL. Is there yeah, I think that's fine. I think that's in the right folder. Okay. Expected type C star const u8 found star const C const u8. Okay, so maybe can we get away with in our C header? Can we write const here to allow that? Or I could probably get away with like a const cast or something. But we'll see. Do optional cause branching problems or no? It will branch in safe mode probably, but in like unsafe mode, I think that it will just deref. Okay, so the Rust side doesn't like that. So that's on shader source. Here we had mute const. Let's double const that now. And hopefully he compiles. There we go. Okay. Can we run it? Okay. Not implemented. Right, so that's better than... Like, that's just kind of expected at this point. So now we can start stubbing out these guys. So the first thing he has to do is shader source. So this is going to be... Can we do something... like, should we wrap this in a function? Doesn't seem unreasonable. Function user data context. And this is just takes in user data, which is going to be a star mute C void and returns a star const flow context. And maybe we even just return a static ref. Maybe that'll make our lives a little easier. Which is kind of a lie, but not that much of a lie, to be honest. Not that much of a lie. Then where were we? We're trying to compile the shader. No, shader source. So we just say user data context from the user data. Let context is equal to this, and then we can do context dot shader source probably, and we probably pass in the shader. Oh, let's look. Oopsies. We might have to do some like bullshit Rust type coercion, which would suck. He does expect an and stir. So stood stir from UTF-8 unchecked. Who needs to check, you know? And this is gonna come from S and length. Okay, so let's see, from UTF-8 unchecked. This is so roundabout. It's funny to go from C-style pointers to Rust pointers so that underneath the hood, it can cast them back into C pointers. What a fun waste of my time. So he needs to create a slice. So we can do slice from raw parts. Okay. So we can do stood slice from raw parts. And he's going to... we actually kind of want like a C-stir here, huh? Kind of want a C-stir. So this is like a stood FFI C-stir from pointer. No. I lied again. Stood slice from raw parts. Let's just double check that we actually passed the length in there correctly. In our main.zig, when we call shader source, we pass in null for the length. Okay, super cool. So I guess FFI C-stir was more correct. From pointer S. Star S, probably. Yeah. Yeah. That's a C string. Yeah. And then this has to go into Glow's shader source, which is expecting a and stir. Which means, so we can say C stir is equal to this thing, and then C stir, oh my god. Oh my god. So this guy must be able to turn into a 2 stir. Yeah. So it's what, like context dot shader source C stir 2 stir unwrap. And then we also have to pass in the shader like this. Going back to work, good luck with your slog. It really do be slog. And appreciate it. Shader, expected native shader found U32. So we probably have to do like try into unwrap or something. F32 is not implemented for U32. Oh, fuck me, man. Because we need to convert this guy into a glow native shader or something. Maybe it's from the context. I forget already. Because here we pulled it out of it with the v.0, which means you have to put it back in. So, native shader. Yeah, so we just say glow native shader like this, probably. And then probably works. Dereference of raw pointer. So here we're going to throw an unsafe on this function name. Okay. That built. That's a good sign. And we hit a not implemented, which is a lot better than a segfault. So maybe this is working. Maybe it's not. But we can just keep going and see. So GL compile shader. This is going to be similar to this, except he's not going to do any string bullshit. He's just going to be compiling shader. So this is context compile shader, and he's going to convert that into a glow native shader, which should be straightforward. It should just be this. Zig build. Okay. Yeah, and then 56. So now we have create program, which is just the same shit. We just do this. Create program. This is gonna have some sort of like error bullshit going on. Probably. So this is gonna be create program. And let's say program. Maybe that all works out. Create program not found in this scope. Well, we can dream. Oh, it's just put an extra thing in there. Not implemented 71. So attach shader, which again, should be pretty straightforward. It should just be, we pull out our context, we attach shader to the program. So maybe, oh, this is fine. Native program from program. Yeah. Yeah, and then let's do 2 lines here because it's hard to figure out which brackets go with which brackets. And this is a native shader. Zig build. Zig build? Are we building? We've built. And then link program is going to look very similar. It's going to look very similar. Link program, and he's only going to use the program. Wait, that's actually working surprisingly well. Not implemented at 41, so there's just a couple left. Delete shader. Which is just going to be a copy paste. Copy, paste, context, delete shader, and we're gonna convert the shader into a native shader. Yeah. Yeah. That seems fine. How is GL delete program not using user data? Wait, that's actually crazy. It actually didn't crash. I mean, we have no proof that it's doing anything. But that's like a really, really, really good sign. Okay. Wait, that's crazy. You know what we could actually do now? We could probably actually test. We could test something here, for sure. Okay, let's add GL clear to our callbacks, and then we should be able to hook that up to the Rust situation. And actually do something. And if that works, we can probably actually call our program soon too. I guess we're missing a few things that we need for that. Let's just start with GL clear color. That's the first thing we're gonna see, like, actual stuff. GL delete program is still unimplemented. Yeah, but luckily we didn't try to delete the program, so it actually doesn't matter yet. So let's do GL clear. What is it? It's a main, or in GUI zig, we set the clear we set clear with this, and we call GL clear color here. So let's add those. So GL clear color takes in 4 GL floats. And then GL clear takes in probably a GL unit would be my guess. But let's see. GL clear. Oh, you meant that's why it's an unused program? Yeah, that makes a lot of sense. GL bit field. That's new to me. Okay. If we implement these two, then we can actually try showing some progress. And that will be cool. So GL clear color. We take in R G B A. This just turns into context clear color probably on the glow side. Probably. RGBA. Yep. RGBA. And I think those should just cast cleanly, I think. And then GL clear takes in a, what is it called? Mask. GL bit fields and user data mute C void gets our context, calls clear with the mask. We have to assign these here, so it's GL clear color is equal to some GL clear color, and GL clears with some GL clear. Okay. Does it compile? That'd be sick. No, of course not. Why would it? Unexpected parameter name. Because I put a colon here instead of a comma, because it's hard. We're chilling. We're chilling. Okay, and now let's make a, here we're called zig hello. We can try clearing there. Zig hello. So here we should be able to say self callbacks. GL clear color. And can we do like something like, we'll make it white. With self, we'll call it GUI data, I guess. Which means that we need to stash the GUI data as a C void. Any opaque. Yep. And so then we have say self user data is equal to user data. And then down here somewhere, wherever the fuck we just were, up here, we pass in. Oh, it's called GUI data here. My bad. And then we call GL clear with the correct bit, which is C GL something bit. Something. Here. Right here. Self callbacks dot this, and that'd be super sick if that worked. That'd be super sick. So let's see. Obviously it doesn't compile. Why would it? So when we construct this thing the first time, we have to write GUI data is equal to null. Never done any video programming. Can you explain why, at least in the early days of this project, the video had rendering with a blue and green layer to it? Okay, so the blue was just because I happened to be clearing the background with blue. The green is because we were looking at uninitialized memory and converting that into RGB, and the uninitialized memory happened to be all zeros, and that all zeros happens to convert into green when you do YUV to RGB conversion. And it's because we were just looking past the edge of the buffer. Wait, that's actually working. Holy shit. I actually expected way more problems here. So if we try to make it like red now, or blue, I should say. Hell yeah. Wait, that's so fucking sick. Okay, so what's happening here? We, from Zig, are launching eGUI in Rust. So we're calling a C function from Zig's perspective that calls a Rust function that starts up the eGUI framework. He creates a window and constructs an OpenGL context, and then starts like running his main loop. On every frame, he says, hey, could we render this rotating triangle thing? And that rotating triangle thing calls back into Zig code through the C interface after passing Zig a bunch of function pointers to call C OpenGL functions that are in Rust land. So we're going like Zig to Rust to Zig to Rust to C is like kind of what's happening there. And it's sick to see that actually working. And you might say, what the fuck are we doing? And it's like, yeah, I agree. What the fuck are we doing? Everybody gets one. Thanks for the tier 1. Appreciate it. We are having fun. We are definitely having fun. That's true. That's for sure. Okay, so I think what makes sense now is we just have to go through the rest of these and fix them all up. And just like add everything that we do in our GUI, and then we can try converting our GUI to use these callbacks, and then maybe everything will just work. Okay, so GL enable for debug output, we can kind of assume that the Rust side takes care of that, so that's fine. Shader stuff we've already done. GL clear color we've already done. Make texture calls GL gen textures. Let's pull these. So GL gen textures. GL gen textures. So this is GL size I and GL uint star. And this is returns void, surprisingly. I guess that makes sense, does it? Where do the textures go? Oh, because the texture's passing by reference. I see. Actually, let's look at the Glow API for this, because the Glow API is sometimes a little different. Gen. This might actually make like a single texture at a time. Create texture. Yeah, this is called create texture and will only ever return 1. So we're actually gonna put a note here and say, well, unless I can create multiple textures, but I don't think you can. Create textures. Yeah, you can only make one at a time. So we'll actually say Note, GL gen textures is not exposed by our GL mappings. You're saying you can? Okay. Textures. Generate texture bitmap. Create. No, I think that the glow bindings aren't propagating it. But I guess we can look at create texture. GL gen textures can, yes. But the Rust bindings are not exposing that capability, I think. Because we have gl.gen textures here. But the only place that's used here is in this create texture thing, which only ever returns 1. So we have to cheat a little bit. So this is just going to return, we take in void star and return a GL uint. Yeah, which is, you could maybe make an argument, by the way, that we shouldn't be exposing each of these functions directly, but maybe we should be writing a little bit more of a sane API. Let's think about that for a second. Does it make more sense? No, it's fine. It's fine. It's fine, we'll do it this way. Because, like, if we were to swap this out for another language and another set of bindings, would we really want to do every single binding individually? Not sure. Maybe I'll think about it off stream, but for now we can just expose one by one, and we'll come back. I'll decide off stream if I'll experiment to see if I like kind of something like, instead of exposing all of this, right? All of these guys could be replaced with make shader from sources or something, where you pass in 2 strings and it just like gives you back the thing, right? That might be more straightforward. Yeah, I'm not sure. I'll have to think about it. So GL gen texture we've done. GL bind texture. Does he return anything? GL bind texture. He returns void. And he takes in a GL enum and a GL uint and a void star, of course, for our user data. And then we need a void GL text parameter I, who takes in probably an enum. GL text parameter I. GL enum param. GL enum, GL int, void star. Okay. Okay, now we gotta go through these ones. GL gen texture, some GL gen texture, GL bind texture, some GL bind texture, GL text parameter I, GL text parameter I. And then all of these guys, they just come here, we copy, we paste, we say GL gen texture. Yeah, I think just making a single make shader from source with takes file path or source string makes more sense. Yeah, I think that I probably agree. But I think that trying that will result in more time loss than just continuing down this path, and I'll just decide later if I actually want to do it. You know, sometimes it's the way it is. Create texture. And then this is failable, so we need to do copy paste this type of shit down here. This type of shit. So this is just going to be replaced with create texture with no inputs. Failed to create texture. And this has to return a GL uint, chilling. GL bind texture is going to be closer to this thing. So this is GL bind texture. He takes in GL enum is probably target. Yep. Target. Then this is going to be the texture, GL uint texture. Oopsies, texture GL uint in this language. And then user data, mute C void. We have our user data turned into context, and we say bind texture with the target texture, and he's going to get mad about some of these guys not matching up, probably. But maybe we'll get that in just a second. GL text parameter I. Is that how we spelled it down here? Yep. Let's see. Let's see. Target pname param. Target pname, and then param was a GL int. Oi, oi, oi. And then what's that look like in Glow? Where are my Glow docs? Are they gone? Text parameter I. Text parameter I32 is what they call it. Text parameter I32. Boom. Target, pname, param. Boom. Yeah, okay. I think that's probably fine. Zig builds. Let's see how fucked it is. Close. We forgot to put some arrows on GL gen texture because I forgot which language we're in. It's a hard life over here. We forget sometimes. Expected native texture found U32. Okay, so this one's kind of interesting. I wonder if I can just do try into unwrap here, or if that's gonna work. Because like a option non-zero U32 is the same as a U32, but that fucking sucks. Okay, so we're gonna say let text is equal to match texture. If it's 0, we go to none. Else, we go to glow native texture try into dot unwrap. That blows, but we gotta do what we gotta do. Expected option found native texture, so this has to write some on it. And then we forgot a semicolon. Of course we did. GUI callbacks does not have the field hello world. I didn't realize I deleted that, but I will take it. Sure, we don't need it. Okay. Okay. What's next? What is next? So we've handled this make texture function. We need delete texture. So what does Glow provide us? Delete texture. Yep. Okay. So this is just GL delete texture that takes in a texture to delete and probably returns void. And what's next? What's next? Delete texture, delete texture, delete texture, delete program. All of that's already done. Bind texture. GL text image 2D we haven't done yet. GL text image 2D. I wonder if we can get away without doing that yet. Like, can we... I want to, like, is there any form of intermediate progress that we can get? Probably not. Probably not. Probably not. Jesus Christ. That's disgusting. Disgusting. Boom, 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 boom. And then, void star here. And then, can we, like... okay. But the rest of this is all already there. And then probably GL active texture we have to do. GL viewport? Do we want GL viewport? I'm actually not convinced that... I'm not sure about this. I think that if the Rust side is setting that up for us, I think we don't need it. This we need. So this will go by the program stuff. So this is going to be void GL use program that takes in a program ID and void star. Okay. And this is going to be a semicolon here. Active texture we need as well. So this is just going to be here. GL active texture. He's going to just take in the texture ID. And GL uniform I. Okay. Void GL uniform I. And he takes in a location, which is probably a GL uint. I'm just guessing. And then another GL uint maybe? I don't know, GL uniform I. Look it up. Look it up. If we want to be good. So it's GL int on both, actually, surprisingly. And we actually need the GL get uniform location as well. So this is just this, but this has to go in a function pointer. This goes like this. Delete, delete, delete. There we go. And is there any more? Draw raise and draw raise. I think this is the last one, actually. Yeah, I think this is the last one. Last one, baby! Let's go! Of course, we still have to implement them all. But, you know. We can dream that it's almost done, and then trick ourselves later. I guess we're tricking ourselves now, and we're revealing the trick later. Delete, delete, delete. Okay. Now, all of the things in Rust need to be stubbed out. So, I actually don't remember which ones I just added, and I didn't add them all in order, which is kind of fucking stupid. I should have done that. GL active texture, GL delete texture. GL delete texture. GL draw arrays. GL uniform I. GL get uniform location. GL draw arrays. All right. Oops, did GL draw his choice like a dumbass? GL text image 2D and a GL use program. Okay. Looks like that's chillin'. Now we can start stubbing them out. So GL active texture takes in a texture as a GL uint. User data, we get our context, and we just say, hello, could we set our active texture to texture? Surely that's it, right? Surely? I guess we'll find out when we fail to compile. Hey, nice, okay. GL delete texture, which is going to look very similar to this, actually. This is GL delete texture, and this is just delete texture, and he's probably going to get mad at me, I'm going to assume, actually, because he probably wants some sort of, like, native texture object. But let's find out. Yeah, he doesn't like that, because he expected native texture. So here, we just say, or native texture, and then we do some conversion bullshit. So, try into unwrap. That's it, but please don't call me Shirley. Yeah, I'm actually calling every single one of you individually Shirley. All of you Shirleys, please keep track of my mistakes. Surely that's a mistake. I guess it's kind of more I'm telling you that you're making mistakes. Do you think that that joke will ever stop being funny? Because surely it hasn't yet. Mode is a GL enum. Then we have first is a GL int, and count is a GL size I, and then we forgot to put user data here on these guys. And so, what does glow draw arrays look like? Here, it's just U32, I32, I32. We're chilling. Actually, mode first count. It can't stop. It was never funny to begin with. Really good point. Really good point. It will always be funny. That's basically what you said. Surely at some point it'll stop. Classic, classic, classic. Okay. This is some GL draw arrays. Uh-oh. Why does it say I'm not connected to chat? Oh, slight blip. Ooh, I was worried I went offline or something. It would really suck for you guys to miss all of this copy pasting, complete brain dead code development. That would really be unfortunate for you. Hate to see you miss out on this riveting content. I think it's location. Actually, I guess we can look here. Fuck. Uniform I32. Uniform. Set uniform? Oh, you set uniform 1 I32 is what they're calling it. So this is location, which is a GL int, and then val, also a GL int. User data is a mute c void. This stuff comes in here. This is uniform 1 I32. We get the look, which needs to be converted into a option uniform location. So uniform location probably can be turned into like glow uniform location lock try into unwrap probably. Then this becomes a sum and lock, and then this becomes a val probably. I don't know, man. Probably doing these like this, if we end up with a bug in here, it's gonna suck to debug. You know? So maybe just like fucking running it instead of looking a little closer is like a really bad decision. Oh, he doesn't like this. How easy is it to mix Zig and Rust in the same project? So we struggled a little bit yesterday. Getting the build systems to line up was a little rough. We tried to use bindgen to like stick a header that was used in both, and that was also a bit of a pain in the ass. So I don't think it's really any harder than using FFI in either language directly. I think it was mostly the Rust stuff that we were struggling with, and I don't think it's actually that bad. Okay, can I jump to definition? No, because my language server's off because it was fucking broken. So we just want to look at, I guess, what was it called? It was a context or native uniform location. Is that not what we did here? Oh, native. I forgot. I forgot to write native. It's a hard life. Oh, but it looks like that compiles at least, which is good. Which is good. Get uniform location. What's that look like? Get uniform location. So here we pass in the program probably and the name, I would guess. Get uniform location. Yeah, program and name. So this is program. We have name, which comes in as a const GL car. Which means that we have to do our string conversion again. So cstir is this from, oops, wrong line. C name is this thing from pointer name, and then we just call context get uniform location starting from the program. So here we need to say glow native program try into unwrap. Then we pass in C name as stir unwrap or something. What was it? It was C stir to stir unwrap, not as stir. To stir. And then we need to return this in some way, which is going to be like some sort of bullshit error handling like this. So it's going to be like all of this goes like this. Boom, boom. Failed to get uniform location with some error, and we return max. Okay. Some GL get uniform location. ION location. Oh my god, we're almost there. We're so close. Does that compile? Obviously not. Why would it? Expected option native uniform location found result. Yeah, I guess we didn't return anything, huh? This needs to return a GL int. Uh-huh. And then here, we return -1, I guess. Okay, v expected option. So this is sum and none. And then there's no error log, I guess. And I guess probably this returns... that's fine. What is it like? From U32 not implemented for I32. At 150, so here. Is this not supposed to be a GL int? Get uniform location? Native uniform location. So this guy is a uint. Is that what it was over here? GL get uniform location. He returns a GL int. So I guess I'll just do this. I don't know. Just like hard cast it. v.0 as GL int. Okay, we're getting close. Found expected U32, found I32. Right, so this is a U in here. Yep, alright. Really chilling yet? Okay. GL text image 2D. Okay, come on, baby. Text image 2D. And okay, so this is gonna require some bullshit because it needs to like extract some slice shit. But we'll get there. So unsafe extern C function GL text image 2D takes in target GL enum level GL int internal format GL int width GL size I oopsies height GL size I order GL int format GL enum type GL enum pixels const void. Okay, so that all runs up. User data C void. All those types made sense. Also, Stranger's Choice by Glow. Get uniform locations documented, sometimes returning -1. Yeah, but I guess that in that case it returns a none type, so it's okay. Right? He wraps it with like some like Rust bullshit, so I guess it's fine. But yeah, that was surprising to me as well. Okay, so I guess here we just we do the same thing. We get our context and we just pass all the shit in. Context, text, image, 2D, and then we just kind of slap all this in here, except that pixels is going to be something else. So we replace all of these with commas, and then we just need to figure out how to deal with pixels. So I guess we actually need to do some sort of like slice conversion here. So we'll start with this as const u8. And then how are we going to know the size of this thing? This blows. I guess it's based off of the type that we pass in. Oh my god, it's almost like it would have been so much easier to just have the original functions. Oh well, it is what it is. Okay. So we convert this to U8. Then what? Let's look at what is this thing called again? Text image 2D. Text image 2D. So I think it's this type here is the type of the input type, and we're gonna have to match the size here. So we're gonna like do something like match type. Let pixel size is equal to this. And for now, we're just going to do unimplemented. And then in our GUI, we always use GL unsized byte. So we'll just say blump 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 unsigned byte. Is that in here? Glow unsigned byte is 1. Then we say let pixels is equal to stood slice from raw parts pixels width times height times pixel size. Yeah. And then I think this has to be wrapped in sum. And let's just see how fucked that is. Expected U size found I32. So we'll just kind of width as U size, height as U size, pixel size as U size. Get fucked. 168. He doesn't like this didn't have a comma there. Statement is not surrounded by a body. Help add a semicolon. All right. There's a good chance that that's wrong. But fuck it. You know? I'm so over it that instead of thinking harder, we're just going to skip it, and then later we're going to get mad when it crashes. It's the ultimate fix. We forgo anything now. What do we say? Like, we take pleasure now for pain later. Every time. Fuck future me, you know? We hate that guy. We hate that guy. We like us a lot better. Okay. GL use program takes in a GL uint. User data. So it's just this should just be context use program. And then we probably have to convert it to a glow native program. Program try into unwrap. Please God, let this be it. Some GL use program. Okay, not quite, because this needs to be some as well. Somebody once told me. Surprisingly, it all compiles. That's a nice little shocker. And now, I guess where we're at is it's time to go into the Zig side of things and try to like convert our existing GUI code into using the callbacks. So I think that we have enough Git stuff going for us that we could just kind of start like deleting stuff from here. Probably that's how this probably makes sense. So on init, we're actually gonna do nothing, probably. Let's see. Let's see. What does our API look like? We have GUI run. He calls the render. He gets passed in the renderer. The renderer gets called with set GL callbacks. So maybe what we'll do for now, which is kind of not really what I want, but it's I was gonna say that we could like stick a GUI in here like this, but I don't want to do that. I changed my mind. Instead, we are going to rename init to set GL callbacks. Takes in self as a GUI or self. That makes sense to me so far, and the callbacks also need to be set in here. So this is going to be a const cgl callbacks. Okay. Then what is he gonna do? He also has to take in the user data as well. Okay. And he's gonna store those things in here. He's gonna say, hey, I have some callbacks. Which are const cgl callbacks. And I have some GUI data, which is any opaque. It's something. We don't really know what. And we don't care what. then here is going to say, hey, I'm going to save these guys. And then what? Then what? I guess we're going to delete anything GLFW related, anything GLAD related. So kind of like nuke all this shit. Then here we're going to say self callbacks GL create shader question mark. So basically anywhere where we're calling GL functions now, we just have to replace this with self callbacks. Like this. Self callbacks question mark. Boom, 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 boom. Boom, 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 boom. Yep. So I guess we can just actually search for CGL, and then we can just, like, rip him. Oops. Yep. When using C APIs, why fight the safety feature of one language? You can fight the safety features of two. Yeah, and not to take it, by the way. Lowly C++ dev, I have lots of Rust envy, just inspired by your get fucked approach. Oh, yeah, I mean... Yeah, I wouldn't. Don't worry. You didn't offend me. We're good. I'm just like, I think I'm like barely brain on right now because like, it's so mind numbing what we're doing. Swap frame. What is this? Oh, this is taking in a frame. Yeah. Okay, that's fine. Get actions. So this is just gonna get. We're not gonna support any actions for now. We will deal with that later. GLFW stuff. This goes away. We are not setting the viewport. This is a little concerning that the aspect ratio is unknown, but for now we're just going to set this to 1.0, and we'll deal with that in a second as well. I just want to see if we can get like something that resembles a frame from video. And then we can come back for the rest later. Okay. These all are also CGL. Those would go away. And then I guess this guy now needs to be a member function of GUI. Or it's not called GUI here, it's called self. GL debug callback is gone, error callback is gone. And then wherever called make texture, this needs to be self dot here. Yeah. Okay. And then on initialization, what are we going to do? We're going to return self for sure. And I guess I guess we're kind of just like undefined until we call set GL callbacks. Set GL callbacks is kind of our init. I think that makes sense. And then in main, what we'll do is we'll expose some functions like we had before. This is going to... We're scrapping the Zig renderer concept. Well, let's throw a little commit as a checkpoint. But we're going to ditch this Zig renderer. And this Zig hello, which is actually just our render function, but we're calling it Zig hello for now, is going to take in a GUI, which means that we need to import the GUI. And we're just going to call self-render or something. Yeah. Yeah. Seems reasonable. This stuff can go away, and in set GL callbacks, we're just going to take in a GUI. Callbacks user data. And we're going to say self is equal to GUI init with callbacks and user data. And then our main loop like might work, to be honest. I'm honestly like very much not sure, but it's fun to find out. So we'll just kind of like uncomment all of this shit. What are we going to do? How are we going to run the GUI? Because this kind of blocks everything, to be honest. I guess we can start by doing this. This guy takes in GUI. GUI can no longer be init here. So we're just going to say GUI is a undefined. And he's going to... Or sorry, he's a GUI and he's going to be undefined. We're not going to de-init him because that sounds stressful and difficult. And we're going to disable everything audio related for now. Yup. And then let's just try to get, like, you know, like the 50th frame or something. So we can do something like 0 to 50. Maybe the, like, you know, 100th frame. We're going to update our image basically with this same thing. I guess we have to image de-init first as well. Won't the GUI have to run its own thread eventually? Yep, for sure. But I just want to get, like, something tested right now. So what we're going to do is we're going to get this image, run the GUI. Oh, but we can't update the frame of the GUI until he's initialized by GUI run. But we can cheat. We can cheat and just shove image in global namespace. Right? And then here, immediately call self.swap frame image. And as long as this image gets populated here, then it should work. Maybe. There's a lot wrong here, but we'll get there. It looks like we actually need the audio player to exist for get next video frame to work, so we will do that. Local variables never mutated, const. Okay, use of undeclared identifier window. So in GUI 64, he's got some glfw state that he doesn't want. So let's just get that shit out of here. So we're not using it anymore. Height and width are unused. Okay. And no field named state in struct GUI. Right, so this is in a print. This just goes away. We'll just call this hello from Zig. So I still want some indication of what's happening, so I want that log to still be there every frame, but see, GUI init expected 3 arguments found 2, so what's going on there? Oh, interesting. So we actually want to call like self.init here, which is kind of odd, but it's fine. Error is ignored in here. Is there any errors that can even be returned? I don't know if there are, so if we just delete this here, does that fix itself? Value type of GUI is ignored, so this just should not return. This should be void now because he's initializing himself in place. Expected 2 arguments found run, right? So all of these places where we replace this guy, we forgot to pass in GUI data, which is annoying. So maybe we look for self callbacks. We write a macro that says find the brace, jump to the other one, and put in self GUI data, and then go to the next. I love it when it just works. It does look like that's going into the right spot. Hell yeah, hell yeah. I trust it. Rare that this works this well, to be honest. Love me some Vim macros. Okay. Okay. I fucked one up on a GL create program. The ones where there were no parameters first, it did not inject itself correctly. No field name GL uniform 1i. We probably named it wrong. So that was in our C bindings. GUI common. This should be 1i here, and then in librs we need to fix that to be 1i and 1i and 1i. GL uniform I, which should be 1i. Boom. Dude, do you guys think? What do you think the chances are that this works? Oh fuck. Well, it doesn't even compile yet, so we can get a little excited later. We've got a GUI data on uniform location on GUI 109. So all of these guys need self GUI data. 57. We extract these textures from make texture who returns a GL uint. What is this mad about? This is at 57. Type void does not support struct initialization syntax. What the fuck? Oh, because we're trying to return. So this should be self. All of these get replaced with self dot. What's going on? You're calling C from Rust from Zig? Yeah, so we are using a Rust GUI framework eGUI who has OpenGL bindings inside of him. We want to render something in OpenGL in our Zig land. And so we have to get the OpenGL bindings from Rust into Zig and call it from the Rust render loop, which is called from Zig. So it's like Zig to Rust to Zig to Rust to C. Isn't that fun? Isn't that fun? So we have like an existing OpenGL shader that worked okay. But we're trying to move him into the new GUI framework instead of rendering to a raw OpenGL window. We forgot to do GL uniform 1F, but that should be easy to implement. Sounds fun and chaotic. Definitely is chaotic. I don't know if I would classify this as fun, to be honest. I think this is probably the least fun thing I've programmed for a while. But sometimes you gotta do what you gotta do. You know? Sometimes you just gotta blast through it. GL float. Yep, okay, so on our librs we forgot to do 1F, so the 1F will look a lot like a 1I, but the I's turn into F's. GL float, and this is gonna say uniform 1 F32, and probably everything else just works out, hopefully. I guess we need to bind this down here, so uniform 1I, 1F, 1F, Zig, build. What do you think the chances are that that was right? I was like barely, my brain was barely on for that. I think once you get through all this initial setup, it'll be more fun. No, yeah, I definitely agree. I think it's just the initial setup that sucks ass. I do agree. I do agree. We forgot a self GUI data here and a self GUI data here. Plus, it will be very rewarding if it works, to be honest. GL gen textures. So this GL gen textures we had to replace with GL gen texture, who just now returns a texture like this. I think that was the only real major API change we had to make. Panic. Reached unreachable code. Okay. Can we GDB on this and just see where the fuck we're like fucking up that bad? Oh, it has to be with input video, input Big Buck Bunny. Oh, that's Big Buck Bunny! Holy fuck, man! Holy fuck! I did not expect that to work. I expected that to be not work. Holy shit! Oh, okay, I take it all back. I'm so happy. I'm actually so. I really did not expect this to work. I expected to like bang my head against my desk for like 40 minutes after this. That's so fucking sick. Let's go, baby. Oh, holy. Okay, so we need to fix the aspect ratio stuff. Dude, that's crazy. I really did not expect that to work. That's so fucked. I'm just gonna revel in it for a second. Woo! Okay. So, now. This is the most boring thing to I'm so happy in like 3 seconds. Yeah, it happens like that sometimes. Okay. So, I think the next thing that I want to do here is we need to fix, there's a lot of stuff to fix in here, right? We need to fix the aspect ratio, for sure. But before we get to that, I think that it would be fun to try to figure out the interface for shoving new frames in. So we need to like maybe split out the we need to split out GUI thread, and then we need to inject frames into GUI as we go. And I think that that's achievable within like half an hour. So I think it's worth taking on, because I want to see that progress. But dude, that's so sick. That's actually so fucking sick. This is so what's the word? Ratchet? Is that the word? That's so ratchet. Yeah, well, okay, let's not talk about uncouth women, but it's like, it feels like what we've made here is such like a house of cards. But it's pretty sick. Yeah, pretty sick. Pretty sick. So we've like completely abandoned GLFW and gotten into eGUI, Rust, OpenGL callbacks, Glow, bound through C API, which is like, what a fucking shit show. What a shit show. That's so wretched. I thought it was ratchet. That's what I thought it was. But I don't know. It's just like a word I've heard, and I'm just repeating. Is that how, like, that's how you learn, right? You just hear stuff sometimes, and then you repeat it, and then sometimes you're wrong, and then people go, no, that's not what you're supposed to say. But, you know, it's a little, just happens sometimes. Okay, so we are committing, frame rendered, bone apple tea, yeah, exactly. Frame rendered in eGUI, pog. Okay. Okay. So, in our main Zig, let's see, what are we looking at? We basically need to, we like can construct the GUI here, that's fine. I wonder if it makes sense for us to be able to like construct this thing before sending it off to another thread. Because what I'm concerned about is if we immediately start the next thread here, we're going to try to set, there's going to be a race where we try to send a frame over to the GUI, but he's still going to be in this like undefined state. And there's some intelligent way of fixing this. But there's also an unintelligent way of fixing it. Which is, oh no, wait a second. When they call render, all we have to do is swap frames here. Yeah. And then we don't have to worry about it. And then all we have to do is mutex protect this image. Yeah. Which, you know, there's fix me, of course, this is not how to do this. Right? But if we just want to see something moving, we can just throw mutex in global space, set the image. We can then, here when we swap the frames, we're going to lock the mutex. Like this, right? And then we can just do we can spin the GUI in its own thread. So how are we going to do that? We're going to, I actually have never constructed a thread in Zig. Zig standard library. I want O12, O12O maybe? Nice. Look at thread. How do you compile your program if it's using Rust and Zig at the same time? Yeah, so we hooked into the Zig build system, and we run cargo build in this directory. Then we flag that it generated a static library, and we pass that back as a dependency to our normal Zig build. And so Zig now knows, hey, if this file changed, then that's like, I'm gonna run this command, cargo build. He's going to say, hey, I'm going to check after I run that if libgui changed. And if it changed, then I'll recompile my shit as well. Which isn't perfect. We had some issues there with like some like header consistency stuff at the beginning, but I think for the most part that'll work. There is a little bit to clean up there for sure. For sure, but we're in prototype mode. So we're just doing stuff, and you know, the cleanup comes later. How come I can't jump to this? Because I'm already there. It's an interesting little bug, right? If I'm already on this page, I can't click this. Click, 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 click. So that's kind of interesting. I guess it kind of makes sense because you're already on that page here, even though this is a page, and you're supposed to press escape here, I guess, but arguably a bug that maybe somebody can file PR for. Maybe me. Or maybe we'll just ignore it forever. Okay. How do we spawn a thread? Run. Spawn. Yield. Spawn. Spawns a new thread, which executes a function using args and returns a handle to the spawn thread. Okay. Config can be used for hints, but I don't really give a fuck. Caller must eventually either call join to wait for the thread to finish and free its users, or call detach to execute. Okay. Sure. So all we have to do here is, I guess we don't even have to make a new function. We just say stood thread spawn, spawn config empty, function is c GUI run, and the args are GUI. Yeah. And we say const GUI handle is equal to this, GUI thread, I guess we'll call it. This has to be called with try, and then we'll defer GUI thread dot join. No, detach. I want to say this would not work in a company environment, but there are probably some companies that would do something like this. Yeah, I mean, if I were a real company, one, I wouldn't be using Zig. No offense to Zig. Zig's a great language, but I don't think it's, I would be worried about tying money to it, right? Because like, what if it goes away, right? C++, they've been around for like 50 years. Rust, I think you have like pretty good guarantees it's not going anywhere. But Zig, I think, is a little more in flux, so I wouldn't use Zig. And I would probably, if I were using Zig, I would probably use Qt and just man up and do text rendering myself, right? Because the only reason that we're doing this whole thing to begin with is because I want to be able to take my script and like be like, here is like the script, and I am here. And then I want to be able to be like, and we are clipping here. And we are clipping here, right? And like you can kind of do that with Qt if you were to inject like HTML tags in here, but I like the idea of kind of like post-processing this. So the only reason, and I want to be able to like say, have somebody like click here to here and have that like convert into like a new clip as well. So all of that is like, no, the only reason I'm doing this is because eGUI gives me pixel positions of text, which no other GUI framework I've looked at so far does. And that's the only reason we're doing this. And so like we could dodge all of this if we just laid out text ourselves. Like if we were in a real company using a real set of languages and frameworks, I would just lay out the text manually myself and do this myself, or tank the cost of like injecting color tags and stuff into every frame, you know? But we are here because this is the whole point, right? When I'm like, I want to take some time off and just fuck around, this is exactly why. We don't have to care. What's weird about streaming is that like the thing I'm making actually doesn't matter, which is kind of funny, right? What matters more is that the creation of the thing is interesting, which is just like kind of like a funny, weird, perverse incentive thing where it's like, I've actually noticed that it's beneficial for my stream if I swap projects more frequently, which is bad. But like starting a new topic, people go like, ooh, new, and then they click the button. So it's kind of interesting there. So I have to kind of fight that a little bit and be like, well, what do I care more about? Do I care more about finishing stuff? Do I care more about having fun? Do I care more about the stream? You know, it's just interesting to think about for me. Probably not for you guys. You guys probably don't give a fuck. Am I taking time off between jobs? Yeah, I'm in a year of fucking around, is what I'm calling it. Fun employed is what I've heard some people refer to it as. Okay, so probably what we're going to do is we're going to get rid of this get next video frame loop. We are going to actually initialize our audio player, and we are going to seed the audio player with frames like we did before, with audio frames. Oh no, this is just fixed finding the audio stream, okay? Then we spawn the GUI thread after ensuring that we have a valid image. And then we just do all of this stuff. So our while loop is no longer going to say while the GUI should close. We don't really know that anymore. We're not going to handle any actions. This is just going to be a while true. We are going to... we deleted the action handling code from the GUI, so that's commented out. But we still are going to check it if we want to update the frame. And now instead of swapping the frame in, that's going to happen like globally. So we can comment this out. But we will have to swap the image, the global image thing here. And then this goes away as well. And here we're gonna be hot looping here. So we should probably do something like stood. Is there like a sleep function in this language? There must be. Stood times sleep. And we can sleep for like what is this? 30 milliseconds? 10 milliseconds? That seems reasonable. Seems reasonable. Okay, let's see what happens if we do that. Read declaration of audio player. Oops. Oopies. Oopies. Okay, let's try this. And local variable shadows declaration. This should be like this, which we actually had up here already. Oopsies. Oopies. Okay, let's try that. Expected tuple found GUI. So args here. Where was that? GUI. Thread. Spawn. Here we need to put this in a struct like this. Oh, we actually forgot to lock the mutex around this image. So every time we update the image, okay, this needs to happen down here. And every time we update the image, we should do a lock. So image mutex lock and image mutex unlock. Oh, we're in GB. Okay. What's he mad about? GUI run. Actually, I don't really. Let's get him out of GB because I don't want to worry about it right now. I just want to see what the error message is. Wow. Interesting. So they actually want the GUI thread to be the main thread. How do they even know it's not a main thread? Interesting. Interesting. So what we actually want to do is we want to feed the thread from another. We want to feed stuff from the other thread. So what we'll do here is we will maybe do GUI run GUI like this. That's pretty common. Yeah, I do. Like now that I've seen it, I'm like, yeah, I have heard of that. Like I think I've hit that before, but it's still surprising. So we'll just call this main loop over here. And we'll just take this stuff and shove it in main loop. And we'll do stood thread spawn. What are we spawning? I already forgot. It's the main loop with no arguments, but he needs arguments, probably. Yeah, we'll figure it out. We'll figure it out. So spawn config, right? The function, which is main loop, and the args, which for now is nothing, but it's not going to compile because there's going to be a bunch of stuff that he needs. So he's going to need the player state. And he's going to need... Maybe that's it, actually. Maybe it's just the player state, which is kind of a nice surprise. Means that we kind of like made good choices in other like areas. Oh, and I, but this just goes here. And then, oh, okay, we missed some. So decoder. Okay, so this goes here. And then surely there's more. Decoder is not a word, so it's probably video decoder or something. Decoder. Audio player. So this goes audio player. I hope all this stuff can be sent between threads, because if not, that's going to be a pain in the ass. This args lint shit, we can just comment out for now. It doesn't fucking matter. And local. Oh, right. Main loop thread, we'll call this. Because we can't use the same function name as the variable name. Of course not. GUI run needs to be wrapped in C. And player state is never mutated. So this has to be ampersand on all of these, probably. Okay. Decoder has no thing called decoder. Is it called video decoder? Maybe? We could look it up, or we could just guess and check. No field, remember name to detach? Detach. It should be detach. Of course. Okay. Detach. I can spell. Expected audio player found star question mark star audio player. So we'll just do like this, and then like this maybe. Expected decoder found this thing, so we'll do the same thing here. Expected type to decoder decoder. Oh wait, no, that was fine. Why is it angry? Putting the ampersand there seems like what he wants. Oh, because here we're passing in by by reference. Sorry, by pointer in this language. Pass by reference is a C++ thing that I will never get out of my head. So this where's my fucking main loop? Here it is. So it's this decoder goes away like this. Okay. So we're not. Oh! Right. There's this bug. There's this thing in eGUI where it only updates when the mouse moves. But if I hover my mouse over here and wiggle enough, I think. Okay. You know what? I'll fucking take it. Yeah, it's a feature. I mean, it is a feature. I think that's reasonable. Okay, so there's obviously more work to do here. Obviously. But this is a really sick proof of concept. I'm really happy with this. Pausing implemented, check, yeah. Yeah, I'm really happy with that progress for the day. I'm gonna take a break now. I might do some off stream, right? Like the stuff that's left to do, I don't think is like super interesting. I guess a lot of the stuff we did today wasn't super interesting. Right, there was a lot of just like banging out function callbacks, but like the stuff that's left is getting pause state into the GUI. Maybe we'll do that tomorrow. Yeah, sure, we'll do that tomorrow. What else is there? There's like fixing the aspect ratio. I might do that off stream. And then like some like lots of cleanup to be done. So that's cool. We'll be back tomorrow. Actually, maybe we'll skip tomorrow. We'll be back Friday. And we'll just keep going. Progress has been good. So thanks for watching, guys. If you liked what you saw, we stream most days at around 2 o'clock Pacific time. Generally, it's a lot less just banging out code and a lot more thinking. But, you know, sometimes it is what it is. So hopefully y'all come back. If you're new here, there's a YouTube link in the Twitch description where we have all of our previous videos organized by playlist. So if you want to check out like operating system, neural network, some like font rendering and 3D engine stuff, terminal emulator, file system, like video editor, QR code decoder, zlib, git GUI. You know, there's a lot of stuff back here if you want to go check it out. There's a GitHub link in the Twitch description as well where code for all this stuff lives. This stuff will probably get a little bit of cleanup and then polished, pushed there by Friday. Yeah, what else? If you're watching on YouTube, you can swing by on Twitch and say hi if you happen to be online between 2 o'clock Pacific time and now. It's 4 o'clock Pacific time for those of you who are watching live, so anywhere between 2 hours ago and now is about when you should see us. Yeah. I guess we have to do the YouTuber like, subscribe, and then beg for Twitch primes. Yeah. Bye, YouTube and Twitch viewers. Let's figure out who to raid.